Hi, my name is Connie Lyons, and today we will be graphing a linear equation using the y equals mx plus b form. The linear equation, linear standing for a line. Okay, first, a little review. We're going to be graphing on a coordinate plane. Remember, the coordinate plane has an x and a y-axis. The x-axis is horizontal, going left and right. It's like a number line. It has negative numbers to the left and positive to the right. The y-axis is vertical, up and down, like a thermometer, with negative numbers below, positive numbers above. Coordinates of points which we have been graphing are in the form x and y. Okay, first let's look at a coordinate plane. This is a coordinate plane, mostly the first quadrant, but we can move it where we can see the whole coordinate plane. Now, if we were given the equation in the form y equals mx plus b, the m is our slope, the b is our y-intercept. So for this equation, y equals 3x plus 5. The slope is 3, the y-intercept is 5. Okay, the first step in graphing this equation is plot the point 0, 5. You plot the b, the y-intercept. This is the b part of the equation. So let's go to our graph and put the point 0, 5. On the y, you're going to go from the 0, go up 5, and plot the point. Okay, the second step in graphing this equation is to plot another point. You start at the 5, and you're using the slope now, the 3. You're going to look at 3 as a fraction, 3 over 1. It's rise over run. So we're going to rise 3, run 1. So from the 5, we're going to rise 1, 2, 3. Then we will run 1. We're going to put a point right there. You'll probably want to put more than one point to make it more accurate. And if you don't have room to go up, we can go down 3 and back 1, because negative 3 over negative 1 is still a positive 3 slope. Okay, after we've put all the points that we want to put on there, then we will draw a line through the points, and no matter where you move this graph and plot points using the 3 slope, 1, 2, 3, 1, it should fall on that line. This line happens to be a positive slope. Think about if you were going left to right, you would be going up a mountain. So this is a positive slope. Now let's look at one that has a negative slope. Okay, this graph has a negative slope. See, the coordinate of the x is a negative number. This will be a negative slope. Again, the first step in graphing this is by plotting the y-axis. The b, or the y-intercept here, is negative 3. So we will go to our graph and we'll put a dot on our negative 3. Okay, so from the origin, we're going to go on the y-axis to our negative 3, and we'll put a dot, a point on our 0, negative 3. Okay, going back to our equation, the second step, we've done the negative 3. Our second part is to do the slope. We're looking at negative 2 as a fraction of the negative 2 over 1. Okay, negative 2, we're going to go down 2. We're rising negative 2, which is actually a fall, and then we're running 1. So let's go to our graph and do that. From the -3, we will go down 2 and then run 1. So that will be right there. After that, we can put more points. Then we can connect the lines and we have a graph. Now you can look at this one as if you were going from left to right and you get to this line, you're going down a hill. This is a negative slope. Okay, to sum it up, if we're graphing an equation in the form y equals mx plus b, first we graph the b, the y-intercept, and then from the b, from the y-intercept, we apply the slope, which is the coordinate, the coefficient of the x. So first we would graph 4, and up to now we've only graphed whole numbers, but if there's a fraction, you just do the rise over the run. So first we would graph the 4 on this, and then we'd rise 1, run 2, doing it more than once, rise 1, run 2, and then draw the line. Remember, going up is a positive slope and going down is a negative slope. And then later we'll be making t-charts where we pick x numbers, we will plug them into the equation, find the y, and the x and the y gives us a coordinate. We'll also be doing x equals and y equals graphs. I hope you've learned something today, and thank you very much.